Hi there. Let's take a look at Project 7. In this one, we are going to be dealing with dictionaries and functions as we've often had. And again, we're going to deal with a data file. This one we got out of from the United States Census. And it's doing counts of people in poverty. And what we're interested here is children in poverty. And the data, there's data for all 50 states. We're going to take a look just at the Michigan data because we're in Michigan. And what are we going to do? So what we'd like to do is find the counties that have the highest percentage of children in poverty, counties with the lowest percentage of children in poverty, and then go into a loop where we say, okay, give me a county name and I'll tell you what the counts and percentages are. So in the project, we provide a web page for the census, and we're interested just in the data for children. So what does this file look like? Well, the file looks something like that, and the web page has all the information about the data, what's in there. So you have a state code in positions, columns 1 through 2, and 8 through 15 is estimate of people of all ages in poverty, and so on. What we're interested in is the kids in poverty, which if we slice this out, that's column 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's the column 8. Right. And we're also interested in the percentages, 9, 10, 11, column 11. So that's some percentage of kids in poverty. And then we go all the way out to column 20, and that will be the median income. So it gives us an idea. And of course, we're going to then want to have the county names. Now, one of the things you'll notice is that I have the first line is actually for all of Michigan, and so we actually aren't interested in that line. So we're going to ignore that line because we're just interested in the counties. So we're getting information, if we split this, we're getting information out of column 8, index 8, index 11, and index 20. And it would be nice if we could slice out the counties, but there's a little bit of a problem because if we're slicing on spaces, if we're splitting on spaces, we've got some counties that have multiple names. So what we did is, in terms of the county name, it's in these columns, it's in those columns. So we're going to want to take our string and just slice it out. I think that's the easiest way. If you have a different way of doing it, that's fine. The other issue here is that we want to be able to enter a name, such as Eaton, not the county. So I'm interested in the name of the county, or like down here, Grand Traverse. All right, so I would like to, first thing we're going to do is find who has the minimum percentage. All right, what's the smallest percentage in there, and print out the information, the count, the percentage, the median income, and of course we're doing it. We want to know the county that it's in. So we'll find the minimum, we'll find the maximum, and then we're going to start asking for counties. Give me a county. Okay, I type in Bay, and it will give me all the information that each of these columns of data for for Bay County. And we keep going around until we hit a Q or something like that. To stop asking for counties. So that's the basic structure. The columns are on the web page. I actually, in the In the description, we have, we indicate, index 8, index 11, index 20, and some particular columns, so you can get that information, or you have what we want you to do, and then print the highest percentage, the lowest percentage, and then loop prompting for counties. And each time we print the same stuff. We print the county name, the percentage of kids in poverty, the count of kids in poverty, and the median household income. So for that reason, in our specifications, because we're always printing the same stuff, we should have one function that prints the data. And we also require a function to find the highest data, the lowest data, and then create a function that loops to call the different, ask for counties. And then finally, there's a neat little format, because when you're printing numbers like the household income, it's nice to have commas in there. And the specifier here is, rather than :16D, you see a comma in there. And so that'll actually insert the commas in the right place. So in this particular example, I just formatted with 16 comma D and just gave it the number 12,345, and when it printed it out, it was 12 comma 345. So when you're printing the population data and the income data, this prints it pretty nicely. So how does this code work? Well, there's a couple of things we've done differently here. One is, you'll notice that we didn't give you any output. You're going to have to figure that out. Give you the file. So what's the biggest one? What's the smallest one? You figure out whether you got it right or not. There are some things that should be familiar. Basically we have a file, so we're going to open the file. It has a particular name, ex11.txt or something like that, and then we're going to iterate through the file one line at a time, just like we've done a million times before. This time we're going to have a dictionary, right, and that has to start out empty. So that's a curly brace there. And every time I go through my my lines, I want to what are some of the things I have to do? Well, I have to get my county name, right, which is a slice out of the data file, except I just want the county name, not the word county. All right, so that equals line of some kind of a slice. And as a hint, I think you probably want to strip out some spaces off of your data, and you have to remember to get rid of the word county, because we just want the name of the county itself. And then I go and I say, all right, so if my county is in my dictionary, what do I do? Well, actually, if my county is already in the dictionary, then I've got a problem, because that means I've got two counties of the same name. That's a problem. So maybe what I want to do in that case is actually print an error. Otherwise, okay, it's not in there. Let's put it in there. So my county is my key, and that's going to equal something. Right, and you have to figure out what that something is, but we're interested in the data on the counts in column 8, the percents in column 11, the income in column 20, and I put all that into a tuple, and I had appropriate ints and floats in there, And so now that builds every entry, and when I'm done with this, I now have a dictionary by the name of D in this case. Please pick a better name. And that would have all my information. And in fact, what I did is, after I experimented with this and was happy that I had it all correct, I took this whole thing and made a function out of it. You know, just put a def up above, some kind of a function name, and then returned my dictionary. And so, you know, and there are some decisions that you have to make in there. Okay, so how, what am I going to do? How am I going to handle, just getting it down to the county name? And what exactly am I going to put into this this tuple? Do I want to make them into numbers, and so on? I think you probably do, but you get to decide that. And then once you have this, now you can go through and, what do we want to do? The first thing we want to do is find the one with the maximum percentage. Okay, so which entry, however you decided to make your tuple, which one has the percentage in it, and now you want to go through and find the max and print that one. And once you've got that function going, of course, the min is going to be almost exactly the same, except for just a tiny bit different. And then again, we have to have this loop of reading the county. So it says, give me a county. It's like, okay, Kent. And it will print out the information about Kent County. So I'm actually not going to type in any more code than this. And we didn't give you sample output. So you're going to have to do that. We're getting a little further along. I've drawn out a little bit of code here, hopefully to get you started, showed you how the file worked, and I'm going to stop there.